From Cape Canaveral Air Force Station, Florida, United Launch Alliance and Lockheed Martin Commercial Launch Services present live Atlas V launch coverage. At Space Launch Complex 41, an Atlas V rocket is fueled and ready to launch Morelos 3 for Mexico's Ministry of Communications and Transportation.
Range, go for launch. Roger, go for launch.
T-minus 3, 2, 1.
Atlas engine ignition.
Liftoff of the United Launch Alliance Delta IV Heavy rocket.
This is Atlas Mission Control at T-minus 4 minutes and holding. This planned hold gives the launch team time to conduct final systems checks and resolve any outstanding issues prior to entering the terminal count. At this point, we remain on schedule for liftoff at 6:08:30 a.m. Eastern Daylight Time. Our window for this morning's launch is going to remain open for 19 and a half minutes, closing at 6:28 a.m. Eastern Time. Good morning, and welcome to Mission Control here at the Atlas Spaceflight Operations Center. I'm Steve Agate. Thanks for joining us for this early morning liftoff. Morelos 3's delivery on orbit is scheduled to take place nearly 3 hours after liftoff, and because of that long duration, we'll take a break from commentary about 20 minutes after liftoff. We'll resume commentary about 10 minutes before Morelos 3 separation. During that break, we'll continue to show you mission progress. Later in the show, I'll be joined by guests Omar Sharfain from the Secretaría de Comunicaciones y Transportes, or SCT, and Steve Skaladnik from Lockheed Martin Commercial Launch Services. We'll discuss Atlas V, Morelos 3, and the capability it will provide to Mexico. Built by the Boeing company, Morelos 3 will be the second of 2 communications satellites that comprise the Mexsat communications satellite system. Mexsat is a constellation of satellites owned by the SCT. The system is operated by Telecommunications of Mexico that delivers advanced telecommunications throughout Mexico. The Mexsat program is an end-to-end satellite communications system that provides 3G plus communication services to mobile terminals across multiple platforms. Mexsat provides communications to rural zones as a complement to other networks and will also provide secure communications for Mexico's national security needs. Satellite services include education and health programs, voice, data, video, and internet services. We've recently received a final weather briefing from the 45th Space Wing's weather officer. The weather is within the launch commit criteria for this morning's liftoff. The probability of violating launch constraints is only 10%. Ground winds from 12 to 16 knots out of the north, and the temperature is 79 degrees Fahrenheit. So the weather looks good, and we're proceeding towards liftoff with a planned T0 of 6:08:30 a.m. Eastern Time. ULA is using an Atlas V 421 configuration rocket to launch Morelos 3. This is the 57th Atlas V Evolved Expendable Launch Vehicle flight since the inaugural launch in August 2002, and the 100th ULA mission since formation in 2006. A number of important milestones took place leading up to launch. The Atlas V launch vehicle is produced in Decatur, Alabama and Harlingen, Texas. It is comprised of a common core booster powered by the NPO Energomash RD-180 main engine, 2 Aerojet solid rocket boosters, and a Centaur upper stage powered by the Aerojet Rocketdyne RL-10C engine. The Morelos 3 satellite is protected during ascent by a 4-meter diameter payload fairing. The Atlas V Morelos 3 booster arrived at Cape Canaveral on September 8th. The Atlas V booster was erected on its mobile launch platform inside the Vertical Integration Facility, or VIF, on September 14th. On September 17th, the second of 2 solid rocket boosters was mated to the Atlas V booster. On September 18th, the Centaur and payload adapter stack was transported from the dock to the Vertical Integration Facility, or VIF, and mated to the Atlas V booster. The Morelos 3 satellite was encapsulated inside the 4-meter payload fairing on September 21st. On September 25th, the encapsulated payload fairing was transported to the VIF and mated to the Atlas V. Finally, approximately 12 hours ago, the fully integrated Atlas V on its mobile launch platform was rolled from the VIF to the pad at Space Launch Complex 41. Trackmobiles are used to transport the Atlas V to the launch pad, a quarter-mile trip that takes about 30 minutes to complete. Once the mobile launch platform reaches the park position at the pad, the team conducts final securing. Following pad clear, about 4 hours before launch, the Atlas V is fueled and configured for launch. The Atlas V rocket stands 195 feet tall, or about 20 stories, and weighs approximately 1 million pounds fully fueled. To lift the Atlas V away from the pad, more than 1.5 million pounds of thrust is produced by the RD-180 main engine and 2 solid rocket boosters. This is Atlas Mission Control at T-minus 4 minutes and holding. Atlas V will place Morelos 3 into a geosynchronous transfer orbit. Here's a video detailing Morelos 3's trip to orbit. The following profile details the important events of this mission using approximate times.
Go for main engine start. 3, 2, 1, 0. And liftoff of the Atlas V.
The Atlas RD-180 main engine and 2 solid rocket boosters ignite to lift the vehicle away from the pad. Shortly after liftoff, Atlas begins its initial pitch, yaw, and roll maneuvers to attain the proper ascent profile and minimize aerodynamic loads. The Atlas V reaches Mach 1, the speed of sound, at 47 seconds. At 59 seconds, the vehicle experiences maximum dynamic pressure. At 2 minutes 9 seconds, the 2 solid rocket boosters, or SRBs, are jettisoned. Approaching booster engine cutoff, the Atlas V is burning propellant at a rate of 1,672 pounds per second, traveling at approximately 12,576 miles per hour, and located 84 miles in altitude and 277 miles downrange. Booster engine cutoff occurs 4 minutes 9 seconds after liftoff. 6 seconds later, the booster stage is jettisoned. The first Centaur main engine start takes place 10 seconds after booster separation. At 4 minutes 33 seconds, the payload fairing is jettisoned. Cutoff of the Centaur main engine occurs 18 minutes and 9 seconds after launch. The mission now enters a 2.5-hour coast phase. At 2 hours and 48 minutes into the flight, the Centaur main engine is restarted. This burn will last just under a minute. Following the second Centaur main engine cutoff at 2 hours and 49 minutes, the mission enters a short coast phase in preparation for spacecraft separation. At just under 2 hours 52 minutes, Centaur releases Morelos 3.
L minus 10 minutes.
As I mentioned earlier, today's Morelos 3 mission is the 100th ULA launch since company formation in December 2006. In less than 9 years, ULA's Atlas V, Delta II, and Delta IV launch vehicles have delivered 63 national security missions, providing life-saving capability for our men and women in uniform, including 15 GPS satellites, 14 communications satellites, as well as weather, missile warning, and reconnaissance missions. ULA's first 100 launches also includes missions that made extraordinary discoveries, like NASA's Kepler and RBSP, missions such as NASA's Aquarius and SMAP that help us better understand our planet, missions to the Sun, the Moon, Mars, and Jupiter that allow us to look beyond our planet, and the first exploration flight test, a critical first step to reducing risk for crewed missions to distant locations. And finally, vital commercial missions providing communications and Earth imaging capability to people across the globe.
Launch on time verified.
Roger. Verify solar radiation acceptable for launch.
Verified.
This is Atlas Mission Control at T-minus 4 minutes and holding. In a few moments, launch conductor Doug Lebo will poll the team for the final go to pick up the countdown. 27 engineers and managers will be polled for system status and readiness to proceed with the launch. This is the final status check before launch for all Atlas vehicle systems, ground systems, the spacecraft, and the U.S. Air Force Eastern Range. The readiness poll includes hydraulics, pad water deluge system, electrical systems, pneumatics, propulsion systems, flight control, and propellants. Let's listen in as launch conductor Doug Lebo performs the final polling of the team.
Status check to proceed with terminal count. Atlas systems, propulsion. Go. Hydraulics. Go. Pneumatics.
Go.
LO2.
Go.
Water.
Go.
Centaur systems, propulsion.
Go.
Pneumatics.
Go.
LO2.
Go.
LH2.
Go.
Has gas.
Go.
Electrical systems, airborne.
Go.
Ground.
Go.
Facility.
Go.
RFFTS.
Go.
Flight control.
Go.
Instrumentation.
Go.
COM.
Go.
Timer.
Go.
GCQ.
Go.
Umbilicals.
Go.
ECS.
Go.
Redline monitor.
Go.
Quality.
Go.
Op safety manager.
Go.
ULA safety officer.
Go.
Vehicle system engineer.
Go.
Anomaly chief.
ACs go.
Range coordinator.
Clear to proceed.
Launch director.
You have permission to launch.
Proceeding with the count. T0 is planned for 10:08:30 Zulu. Set count to start at 10:04:30 Zulu.
Roger. T0 is set for 10:08:30 Zulu. Count will start at 10:04:30 Zulu.
Polling is complete and the launch team has given the go for launch. The countdown will resume approximately 2 minutes from now. From T-minus 4 minutes until launch, you'll be listening to launch conductor Doug Lebo and his team performing the final steps in the countdown procedure. You'll hear the team call out that Atlas LO2 topping has been secured, followed about a minute later by the call out for transferring the Atlas and Centaur stages from ground facility power to internal battery power. At T-minus 1 minute 55 seconds, the team will command the launch sequencer to start, followed shortly by the securing of the Centaur LH-2 and LO-2 topping activities. At T-minus 1 minute 40 seconds, the team will command the flight control system to launch enable and arm the flight termination system. In the final minute, the Atlas tanks will be verified at flight pressures, followed by the verification of Centaur tank pressures. Final status check of Atlas, Centaur, and Morelos 3 readiness is conducted at T-minus 25 seconds. Seconds before liftoff, the RD-180 engine ignites and performs a health check, followed by the ignition of the 2 solid rocket boosters. After liftoff, you'll hear the voice of Marty Malinowski providing launch vehicle ascent data.
On my mark, the time will be T-minus 4 minutes and counting. 3, 2, 1, mark. T-minus 4 minutes and counting.
3:55.
The countdown clock has resumed and we're proceeding towards a 6:08:30 a.m. Eastern Time liftoff.
Three minutes.
Securing LO2 topping.
Atlas tanks to flight pressure.
250.
FTS internal.
T-minus 2 minutes 29 seconds and counting. Once the rocket lifts off, it will only take about 47 seconds to reach Mach 1, or the speed of sound.
$159.
Vehicle internal. Launch sequencer start.
$150.
Securing Centaur LH-2.
Securing Centaur LO2. 140.
FCS launch enable.
FTS armed.
T-minus 1 minute 30 seconds and counting. The launch vehicle, payload, ground systems and Eastern Range are go for launch.
120.
Orcas armed. FCS count started.
110.
Vent valves locked.
T-minus 1 minute.
Rock, report range status.
Range, green.
Hold. There's a MIFCO on channel 1 with a hold due to fouled range.
Launch conductor is not ready. Clock is stopped at 51 seconds. All personnel go to section 80 for recycle. Flight control, state cause and time of abort.
This is Atlas Mission Control at T-minus 51 seconds and holding. We've had a hold to the count called by the range for a fouled range status, and we'll bring you back additional information as soon as we receive it.
Centaur pneumatics.
Go ahead.
Roger, step 20.
And venting is complete. Tank pressures are stable.
Roger.
Atlas tank pressures are stable.
Roger.
T-Bios inactive.
This is Atlas Mission Control at T-minus 51 seconds and holding. The team is now preparing to recycle the count to go to the T-minus 4-minute mark. At the T-minus 4-minute mark and holding, we will inform you as soon as that official time is communicated to us. But again, at 51 seconds right now, recycling the clock to T-minus 4 minutes and holding. This is Atlas Mission Control.
And FTS, if you can verify FTS safe and external.
FTS is safe and external.
Roger. LC, go ahead. LC switch is in the not ready. Flight control, verify battery heater power applied.
Verified.
LCLD channel 1.
Go ahead, LD.
All right, please set up for the end of the window. The range is assessing their ability to support. We need to put in our request and align our team to a UTC time of 10.
This is Atlas Mission Control at T-minus 51 seconds and holding. We'll be recycling the count to the T-minus 4-minute mark. The new established T0 time that we are aiming for is the end of the window at 6:28 Eastern Time. Again, we're trying to reestablish the count to proceed for an estimated liftoff time at 6:28. That would be the end of the window. This is Atlas Mission Control.
T-minus 4 minutes and holding.
Roger. Timer, reset the countdown clock to T-minus 4 minutes and holding.
Roger. T-minus 4 minutes and holding.
Roger. And timer, please set the clock for a new T0 of 10:28:00 Zulu. All stations, recycle systems back to T-minus 4 and holding configuration. Occurred at T-minus 51. Report status at completion.
This is Atlas Mission Control. We've reset the clocks here at the T-minus 4 minute and holding mark. Right now at this time, the team is recycling to the 4 minute mark, putting our vehicle to where it would have been in the T-minus 4 minute before we begin the countdown again. Again, the countdown is expected to start at T-minus 4 minutes at 6:24 a.m., leading to a potential liftoff time at 6:28 a.m. Eastern Time.
Step Juliet, RFF is ready. Roger.
Step Kilo, flight control ready.
Roger.
This is Atlas Mission Control at T-minus 4 minutes and holding. We received word that the cause of the hold T-minus 51 seconds was due to a boat in what is called the falling debris zone off the Cape here. And right now the boat is we're trying to relocate that craft so we can pick up the count again at the T-minus 4 minute mark at 6:24 a.m. We're expecting to have that liftoff at 6:28 a.m. Eastern Time. This is Atlas Mission Control.
Charlie, Atlas Propulsion System stable. Roger. Delta, Atlas Hydraulic System stable. Roger. Step Lima, GC3 ready. Roger.
And LC, CEC is active, and Centaur pneumatic systems are stable.
Roger.
Centaur LO2 continuing topping and has gas ready.
Roger.
This is Atlas Mission Control at T-minus 4 minutes and holding. We've just received
LC,
word
step
that
Mike.
that errant boat is now clear of the fallen debris zone, and we should be ready to resume the count at the 6:24 a.m. for a liftoff at 6:28 Eastern Time.
OSM, LC.
OSM, go ahead.
Roger. Place SRB ignition SNA switch to the enable position.
SRB to enable.
And OSM, verify the FCO, RCO, and OSM hold fire switches are in the proceed position.
LC, stand by. We're trying to get MIFCO to reset theirs.
Roger. Flight control, LC.
Go ahead.
Perform launch on time verification.
LC, OSM.
Go ahead, OSM.
Roger.
All hold fire switches are in the proceed position.
Roger. And redline monitor, verify redline monitor and event table are in the correct configuration for terminal count.
Verified.
Launch
LC.
time verified.
Roger, flight control.
LC ALO.
Go ahead, ALO.
Atlas LO2 topping is in progress.
Roger. LC, busy LC on 1. System recycle is complete. LC switch going to ready position. All personnel return to the L-7 minute status check. Launch director, LC.
LD.
Roger, launch vehicle system recycle is complete, and we are holding at the L-7 point to pick up the status check here at L-7.
LD copies. Thank you. Good recycle.
This is Atlas Mission Control at T-minus 4 minutes and holding. In a few moments, launch conductor Doug Lebo will poll the team again for the final go to pick up the countdown. Let's listen in as launch conductor Doug Lebo performs this final polling of the launch team.
Status check to proceed with terminal count. Atlas systems, propulsion, go. Roger, propulsion. Hydraulics,
Go.
pneumatics,
Go.
LO2,
Go.
water,
Go.
sensor systems, propulsion,
Go.
pneumatics,
Go.
LO2,
Go.
LH2,
Go.
has gas,
Go.
electrical systems, airborne,
Go.
ground,
Go.
facility,
Go.
RFFTS,
Go.
flight control,
Go.
instrumentation,
Go.
comm,
Go.
timer,
Go.
GCQ,
Go.
umbilicals,
Go.
ECS,
Go.
redline monitor,
Go.
quality,
Go.
op safety manager, OSM, LC,
Go.
ULA safety officer,
Go.
vehicle system engineer,
Go.
anomaly chief,
ACs go.
range coordinator,
Clear to proceed.
launch director,
You have permission to launch.
proceeding with the count. T0 is set for 10:28 Zulu. Set count to start at 10:24 Zulu.
Roger. T0 is set for 10:28 Zulu. Count will start at 10:24 Zulu.
Polling is complete and the launch team has been given the go for launch. The countdown will resume about 2 minutes from now. After liftoff, you'll hear the voice of Marty Malinowski providing launch vehicle ascent data. This is Atlas Mission Control at T-minus 4 minutes and holding. We anticipate releasing the hold in just a few moments.
1, mark. T-minus 4 minutes and counting.
3:55.
Ground power is enable.
The countdown clock has resumed and we're proceeding towards a 6:28 a.m. Eastern Time liftoff.
Three minutes.
Securing LO2 topping.
Atlas tanks to flight pressure. 250.
FTS internal.
T-minus 2 minutes, 29 seconds and counting. Once the rocket lifts off, it'll take only about 47 seconds to reach Mach 1 or the speed of sound.
$159.
Vehicle internal.
155.
Launch sequencer start.
150.
Securing Centaur LH2. Securing Centaur LO2.
140.
FCS launch enable.
FTS armed.
T-minus 1 minute, 29 seconds and counting. The launch vehicle, payload, ground systems, and eastern range are go for launch.
120.
Orca is armed. FCS count started.
110.
Vent valves locked.
60.
T-minus 1 minute.
Port range status.
Range green.
$40.
Stable at step 3.
T-minus 30 seconds.
25.
Status check.
Go Centaur.
Go Morelos 3.
20. 15.
This is Atlas Mission Control at T-minus 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0. RD-180 ignition. And liftoff. Liftoff of the 100th United Launch Alliance rocket. The Atlas V is carrying Morelos 3 for Mexico's Ministry of Communications and Transportation and Lockheed Martin Commercial Launch Services. Morelos 3 will deliver advanced mobile telecommunications throughout Mexico.
Attack phase of flight. SRP chamber pressures have peaked and are rolling off now. Program's complete and we are throttling down. Mach 1. back up. Engine response looks good. Pump speeds, injector pressures. Max Q.
You're hearing the voice of Marty Malinowski providing launch vehicle ascent data. Let's listen in for mission progress.
Continue to burn well. Pump speeds, injector pressures on the RD-188. Good. Body rates controlling down the middle. Coming up on SRB burnout. And SRB burnout has occurred. Boosters now throttling back up to 100% thrust. Engine response looks good. Current altitude is 18 miles, downrange distance 15 miles, current velocity 2,824 miles per hour. Booster engine performance continues to look very good, body rates controlling down the middle. Coming up on SRB jettison shortly. And closed loop steering has been enabled, now flying Q alpha limited steering. RCS pyro valve has been fired. System's now pressurizing the flight levels. Closed loop integral steering is underway. Currently accelerating at 2.8 Gs. Engine performance looks very good. Body rates are good. Range track shows making good progress right down the middle of the range. Currently flying at an altitude of 47 miles, downrange distance 103 miles, current velocity 6,590 miles per hour. Still accelerating smoothly at 3.7 Gs. Booster engine continues to operate well. And we have begun boost phase chill down and are beginning throttle to maintain 5 Gs. And boosters throttling back to maintain constant 4.6 Gs in preparation for BECO. Boost phase cooldown is complete. And we have BECO. Engine shutdown looks good. We have retros and stage separation. We have LOX and fuel pre-start. GN2 purge for into the RCS is underway. We have ignition and full thrust on the RL-10. Centaur closed loop steering has been enabled. Body rates look good. LOX tank pressures have vented down as expected. Storage bottle pressures look good. Centaur PU is now in closed loop control, controlling near nominal. RCS line temperatures are warming towards bottle temperature. Current altitude is 107 miles, downrange distance 465 miles, current velocity 12,611 miles per hour. RL-10
This is Atlas Mission Control at L plus 5 minutes 25 seconds into the flight. We've just heard Marty Malinowski confirm successful completion of the early phase of today's mission. All systems continue to operate nominally. The Morelos 3 mission is currently in the first of 2 Centaur upper stage engine burns. Our next event, the Centaur main engine cutoff, will occur in about 13 minutes. I'm now joined by Steve Skolodnik, president of Lockheed Martin Commercial Launch Services. Steve, thanks for joining me.
It's my pleasure to be here.
Well, Lockheed Martin Commercial Launch Services is supplying the launch for the Mexican government today. How do commercial Atlas launches work?
So, as you well know, Steve, the United Launch Alliance is a joint venture between Lockheed Martin and the Boeing company. United Launch Alliance is in place to service the U.S. government market space. So the parent companies, Boeing and Lockheed Martin, will market their respective products to the commercial market space and to the international market customers around the world. So when a commercial customer or when an international customer would like a ride on an Atlas rocket, they would contract for that service through Lockheed Martin, and then I'd turn around and request the assistance of United Launch Alliance to actually perform that service.
I see. What do commercial customers like about launching on an Atlas?
Steve, the Atlas vehicle is considered around the world as literally the gold standard for launch services. It is the most reliable launch vehicle in both terms of performance and in terms of date certainty. A satellite sitting on the ground really does a customer no good. They can't generate any revenues from it. In fact, it costs them money sitting on the ground. So to get a satellite into orbit on time when they expect it to, so that they can be providing the services that they are on contract to provide to their customers, is absolutely critically important. And Atlas has almost a perfect record in making sure that we achieve not only mission success but on-time performance as well.
Well, this is a commercial launch. Commercial launches usually occur for commercial customers, but this is a launch for the Mexican government. How has it been working with a government customer?
When you're dealing with international customers, their needs and their requirements are really not that much different than a commercial customer. They have their customers. The government of Mexico has their customers as well. In this case, this particular satellite is servicing the defense community within the government of Mexico. So my customer, the communications ministry within Mexico, has to provide services to their customer and has to do so on a timely basis and on a mission assured basis as well. So really it's not that much different.
Well, Steve, you've been to many launches before. How do you feel right now in the middle of this flight?
You're absolutely right, Steve. I have been to a lot of launches, but every launch is different, and every launch has its own unique character. In this case, being for an international customer, the accents of the applauses are a little different. But I have to say, every time I see the T0 hit and I see the rocket take off, I still feel like a little kid at heart to see it take off.
Well, that's great. Thanks for all your insights into this important capability for Mexico. Now let's get back to the mission.
61 miles, downrange distance 1,313 miles, current velocity 14,430 miles per hour. Centaur PU continues to run slightly oxidizer rich. Chamber pressures, LOX pump discharge, and fuel venturi all look good for the set MR. RL-10 continues to perform well. All systems look good at this point. Centaur battery rates continue to control right down the middle. RL-10 performance continues to look good for the oxidizer rich mixture ratio. Centaur currently is flying at an altitude of 154 miles, downrange distance 1,850 miles, current velocity 15,923 miles per hour. RL-10 continues to look very good, still controlling slightly oxidizer rich. RCS thermal conditions all look very good, continuing to see periodic thermal conditioning firings on that system. Centaur is accelerating at 0.6 Gs. Centaur continues to look very good. RL-10 performance is nominal for the ZMR. And we have IAP vanish at this point. Centaur is orbital. Less than 5 minutes remain in this burn. Centaur tank pressures, storage bottle pressures, and batteries look good. Continuing to see our thermal conditioning firings in the RCS. RL-10 performance is nominal for the ZMR. Four minutes remain in this burn. All systems look good. Currently flying at an altitude of 125 miles, downrange distance 2,649 miles. Current velocity 18,422 miles per hour. RL-10 chamber pressures, LOX discharge, and fuel venturi all look very good. Pump housing temperatures are in the expected range. RCS temperatures look very good and stable. Still controlling oxidizer rich. .930 seconds into the mission, Centaur continues to perform well. Still requesting an oxidizer-rich condition. RL-10 performance looks good. RCS is stable. Tank pressures and bottles look good. Batteries are stable as well.
This is Atlas Mission Control at L plus 16 minutes and 2 seconds into the Morelos 3 mission. All systems continue to operate as expected. The Atlas Centaur second stage and Morelos 3 satellite are currently located over the Atlantic Ocean, flying on a southeasterly heading east of Antigua. Our next event, the first Centaur main engine cutoff, or MECO 1, is scheduled to take place in about 3 minutes. Here's Marty Malinowski.
16 miles per hour. Centaur PU is still slightly oxidizer rich. RL10 performance looks good, however, for the NMR. Less than 1 minute to MECO. RL10 continues to look very good. RCS just seeing light thermal conditioning firings. Body rates controlling down the middle. All systems look good coming up on MECO. And we have MECO engine shutdown looks good. We have 4S settling.
As Marty Malinowski just reported, the Centaur main engine has completed the first of 2 burns in its mission to deliver the Morelos 3 satellite to geosynchronous transfer orbit. This mission is now in a 2.5-hour coast phase. The Atlas V is now located over the Atlantic Ocean off the west coast of Africa and continues to travel on a southeasterly heading. During this coast, the mission will continue in a southeasterly direction, crossing over the southern African continent, after which the heading will turn slightly north. Following the long coast, the Centaur RL-10C engine will be restarted for a final 1-minute burn. A nearly 3-minute coast will follow the burn. The mission will then end with the Morelos 3 separation, scheduled to occur at just under 2 hours 52 minutes after liftoff. As a reminder, because of the long duration of this morning's flight, we'll take a break from commentary in a few minutes, but first, I'd like to introduce to you Omar Sharfain from the Morelos 3 Program Manager.
Thanks, Steve. It's a pleasure.
It's an exciting day for you and the government of Mexico. Can you tell us more about the Morelos 3 satellite?
Yeah, sure. As you said, it's an exciting day for us. The Morelos 3 satellite is the second satellite of our Mexsat fleet. The first one was the Bicentenario satellite that was launched in 2012 and it's been operated by Mexicans in Mexican territory since 33 months ago. This Morelos 3 satellite is very important because it will provide mobile communications to different national security agencies all around the country to serve as a complement to other networks that we already have for national security purposes.
How does Morelos 3 fit into the whole Mexsat system?
Well, as I said, it's the second satellite of our fleet, but this one has specific importance because it will provide different communications through different platforms. That's why we have, for example, a huge L-band reflector on the satellite so that we can have in-ground small terminals, handheld type, but we will also be able to communicate and provide connectivity through other platforms for aerial terminals, maritime and vehicular as well.
Okay. What are some of the critical services that Mexsat and Morelos 3 will provide to the Mexican people living in remote parts of the country?
Well, they will serve as a complement to other networks that we have. We will be providing connectivity and telecommunication services such as voice, video, and internet to public schools in rural areas, and also to hospitals and libraries and public or federal buildings.
That's excellent. This is an important launch. We still have about 2 hours and 30 minutes until we deploy. How are you and the team doing?
We're doing fine. I think this was an exciting launch with the hold that we got on 51 seconds prior to liftoff. So it just added excitement to the mission. But as you said, it's a long flight, so we still need to wait till the end.
That sounds good. Omar, thank you so much
Thank
for
you, Steve.
joining me.
Thank you very much.
Thank you. He said, this is Atlas Mission Control at L plus 23 minutes, 38 seconds into the flight. The Morelos 3 mission is in an extended coast phase, and all systems continue to perform as expected. We'll take a break from commentary now. We'll resume commentary at 9:10 a.m. Eastern Time. Again, we're taking a break from commentary now, and we'll resume commentary at 9:10 a.m. Eastern Time.
Battery voltages look good. RCS continues to show periodic settling maneuvers. .2400 seconds, mission elapsed time. All systems are still stable on the Centaur as we begin our coast over the Indian Ocean. And at this point, we are seeing some minor data dropouts, but data flow has resumed. Quality looks good. All systems continue to be stable, still rolling at -1.5 degrees per second. Still settling at 6.5% duty cycle on the 4S motors. Everything looks good. At 3,100 seconds, mission elapsed time. All systems continue to look good. Still rolling at -1.5 degrees per second. Still settling with 4S motors at a 6.5% duty cycle. Tank pressures remain stable, as well as battery voltages. And Centaur has begun its second PTC roll reversal. Still settling at 6.5% duty cycle on the 4S motors. And Centaur has completed the PTC roll reversal, now rolling at +1.5 degrees per second, still in the same PTC orientation. Still settling at a 6.5% duty cycle on the 4S motors. At 4,100 seconds, mission elapsed time, Centaur is still coasting over the Indian Ocean. Current altitude is 6,818 miles. Downrange distance is 11,416 miles. Current velocity is 11,832 miles per hour. At this point in the mission, Centaur continues to roll at 1.5 degrees per second. Body rates still are stable. Tank pressures are flatlined. Storage bottles look good. Batteries are stable, still settling at 6.5% for us. And RCS line temperatures look very good. All systems are in great shape for this point of the coast. And Centaur continues its PTC roll at 1.5 degrees per second. Still settling at a 6.5% duty cycle at 8-second intervals. Tank pressures and batteries are all stable. And Centaur has begun its third PTC roll reversal. All other systems are stable at this point in the mission. And Centaur has completed the PTC roll reversal, now rolling at minus 1.5 degrees per second. All other systems look good at this point. And Centaur has begun 6.5% duty cycle at 4-second intervals for the 4S settling sequence. Signatures look good. RCS line temperatures still very warm. Tank pressures look good. Centaur is now halfway through its 2.5-hour coast and should be visible by Guam by now. And Centaur has begun 40% forest settling in preparation for the parking orbit coast flip. Signatures look good. And Centaur has begun its ecliptic turn, still rolling as it makes this maneuver. And Centaur has completed its ecliptic mid-coast flip, still rolling at -1.5 degrees, still settling at a 40% forest duty cycle. All their systems are stable at this point. And Centaur has begun to ramp to a 6.5% forest duty cycle. Signatures look good. Still rolling at -1.5 degrees per second.